Okay, now we'll take a look at problem 4. So we have a boiler at sea level contains superheated steam at 0.575 megapascals as an absolute pressure, and it's at 300 degrees C. Okay, this problem, find the gauge pressure in the boiler and the steam temperature in units of Kelvin, Rankine, and Fahrenheit. Okay. Okay, so so the first part of the problem, just write down what we need to find: the gauge pressure, temperature in Kelvin, temperature in Rankine, and temperature in Fahrenheit. Okay. So here's what's given. We're given the temperature in degrees C. We're given the absolute pressure in megapascals. I just converted it over to kilopascals because there's 1,000 megapascals in a kilopascal. I'm sorry, 1,000 kilopascals in a megapascal. Okay. And then I have atmospheric pressure. This is just, look this up in a table. This is at sea level, 101 kilopascals. Okay. So here's the governing equations. All we need to do is find gauge pressure, which is the absolute minus the atmospheric, temperature in Fahrenheit, given temperature in C, temperature Kelvin, given temperature in C, and the temperature in Rankine, knowing that the first part we found the temperature in Fahrenheit, we just add 459.67 to that. Okay. All right, so the next part of the problem, part 2. Okay, so this is just the approach. First part is finding the gauge pressure, which was just the absolute pressure minus the atmospheric pressure. So simply just plugging in and performing the calculation. The second part is applying the temperature in Fahrenheit conversion formula from temperature in degrees C. And the same thing, you just perform the calculation. 1.8 times 300 degrees C plus 32 gives us a 572 degrees Fahrenheit. The next one is just applying the formula to figure out temperature in Kelvin, given temperature in C, and we perform this operation, it becomes 573 degrees C. Then the temperature in Rankine, given temperature in Fahrenheit, which we found in step 2, and we add to 459.67, and when we do that, we add that, plus our 572, which we found in step 2, we add those two together, we come up with the 1032 degrees Rankine. And that's that.